California's Yuba River starts high on the western slope of the Sierra, a composite of the Slate, Indian, Canyon, and Snake, fed by tiny nameless creeks clattering toward it from either side, by glistening springs trickling over its mossy banks. As it slows its pace on the more gentle slopes of the land below, the pine and cedar on its sides give way to the gnarled oak, the tangled manzanita and underbrush to open grassland. Slower now and wider, it reaches Marysville and yields its weight and identity to the better-known Feather River. The land the lower Yuba bisects is part of California's productive valley farmland, a rural area geared to the echo of tractor and harvester, the lowing of cattle, to the tattoo of fresh fruit cascading into wooden lugs. An average year brings 17 inches of rainfall between October and May. Settlers in early days found this pattern ideal for growing wheat. More ambitious folk who followed, though, figured the area's dependency on wheat could be lessened and the dry summer months made more productive by diverting river water into their fields, irrigating and diversifying their crops. Instead of just wheat, they grew beans, rice, feed grains, and fruit. Anxious to share the profits of this new bonanza, the wheat farmer joined the crowd, began plowing up his fields to replant, irrigating, leveling more land, and as his fences reached further away over the horizon, seeking more water for his thirsty new fields by pumping from wells. The fields stretched ever wider, and the pumps went deeper and deeper to find more water. Many farmers found that at a certain depth, the water they brought up was saline, not suitable for irrigation.
In one 15-year period here, the water table dropped 2 feet a year. Some places they used to get water at 75 feet. Now they've got to go down 240.
Some tried independent approaches to diverting and storing river water, springs, and runoff. No one plan seemed to be just right for everyone. They began backing off, pumping less water, planting fewer crops. The water table kept dropping. And then, about once every 8 years, the Yuba came up, and there was more water than you could use. In the streets, in the fields, in the houses. One of the better-known experts on the foibles of the Yuba and champion of campaigns to control it was the late W.T. Ellis, who wrote a book about the up-again, down-again river. He was so much a part of the scene that when he died, they erected a monument to him on a bank of the levee. History always repeats itself. Remember the winter of 1861-62. Always be prepared. Always be alert. And always watch the tricky Yuba. 4 months after he died, a disaster that he had predicted. The 1955 Yuba City-Marysville flood was a major disaster in terms of lives lost and property damage, and was largely responsible for, at last, something being done about the Yuba. Out of a seemingly endless series of meetings exploring the problem, the Yuba County Water Agency was born in 1959. Its primary objective, the control and conservation of Yuba River water with construction of a dam. A dam to provide flood control, conservation of water for agriculture, a new source of hydroelectric power, a mammoth lake for year-round recreation. To finance the project, the agency put before county voters in 1961 the largest election of its kind in history, $185 million in revenue bonds, more than twice the total assessed valuation of the county. The voters approved it. Where do you start on a $185 million project to build a big dam across the mouth of a big canyon? Before a shovel was turned, there were feasibility and design studies, state and private water rights to be considered, agreements to be negotiated with a profusion of federal, state, and private agencies whose special interests would be directly involved. State and regional water pollution control boards, the Army Corps of Engineers, State Fish and Game, and the Federal Fish and Wildlife Services, the State Forestry Department, Pacific Gas and Electric Company, and finally, to build the mammoth project, Perini Yuba Associates. In 1966, work began in a steep canyon 5 miles northeast of the town of Dobbins, just downstream from an old dam at a site called Bullards Bar. Start out by moving dirt, tons of dirt. You build access roads into the site. You clear building sites for support operations. You move mountains of dirt to chew your way down to the rock on either side, to anchor the ends of your dam. One of the initial objectives was construction of a diversion tunnel, a temporary channel to divert the river around the construction site. Through solid rock, they burrowed a tunnel 1,700 feet long 48 feet high and 42 feet wide. Big enough to handle a flood, if it had to. Outside, coffer dams were thrown across the river above and below the site to divert the water through the tunnel. And the men and machines moved in to carve out a place for the dam. Major requirements of the contract included 2 tunnels and diversion dams above the main dam to increase water flow into the reservoir, and drilling of a larger tunnel to move a high-volume stream of water from the dam to the new Colgate powerhouse, 6 miles downstream. The Colgate tunnel was 4.5 miles long, and it took crews 19 months, working 24 hours a day, to drill and blast their way through the hard rock. Huge pipe called penstock would carry the water from the tunnel to the powerhouse below. The steep 700-foot drop boosting the force of the stream at the turbines to the equivalent of 212,000 horsepower. Above the dam, springs encountered in drilling the Loman Ridge diversion tunnel caused more water to flow out of it than the normal flow of the stream it was to divert. Some said it was like working in a car wash. Downstream, around the bend from the primary site, work progressed on construction of a rock quarry and on a huge crusher to break the rock into aggregate. The broken rock would later be hauled to the site and, in a batch plant, mixed with cement to make concrete for the dam. It was August 1967, and on both sides of the steep canyon, the solid rock to anchor the dam lay fully exposed. In the river bottom, carpenters began laying the first wooden forms to shape the big concrete shell. The first bucket of concrete on September 13th, 1967, would be followed by the last one 22 months and 350,000 bucket loads later. It would take men, trucks, and equipment just short of 2 years, working around the clock to pour this massive monument on the Yuba. Towering high line, moving from side to side on rails, radio-controlled, swung each bucket into position where it was needed. Pneumatically driven vibrators settled the concrete. A network of water lines laid across the pour at each 7.5-foot level cooled the concrete as it cured. At night, mercury vapor lights strung across the deep canyon like strands of pearls turned dark into day, and the work went on. At the dam, in the tunnels, at the powerhouse downstream. The men rested, went back at it. New men came on at the end of the shift, and the dam began to grow.